Okay, so today we're going to talk about plane curves and what are called parametric equations. So today what we're going to do is sketch paragraphic curves, and then we're also going to express parametric curves in rectangular form. What's another word for a rectangular form? Yeah, the XY plane, right? The Cartesian plane. Okay, and so we have rectangular form, we have polar form that we've been working with, and now we have parametric. Okay, so there are all three of those forms. Your normal XY, polar, parametric. Okay, so what are parametric equations? This is still just a general method for describing any curve, but you can see based on the graph that you've already done and your two new equations that there's another variable that's introduced. Okay, and that variable is going to be t. So I'm just going to give you a really quick overview of what the parametric plane is doing and how that's different. It's actually very similar to your normal coordinates. The only difference is going to be your t value. So you can see on example 1 that our chart is going to have how many columns in it? 3. It's going to have 3. So one of them is going to be t because that's going to be our input. And then our x and our y are both going to be outputs, because there's going to be two equations. So if you look at this box, it says x equals f of t and y equals g of t. So what that means is we're going to plug in t to find our y coordinate, and we're going to plug in t to find our x coordinate. Now when you graph these, you're just going to graph the points x, y. So that's going to be the same as before. You're still going to just do xy, xy, xy. But what the t does is it sets a parameter. So when you think of a parameter, what's a synonym for that? Okay, like a limit, right? Like a boundary. So a parameter is going to be in certain intervals, and they call that I. So t is in the set of I where you're going to have a certain interval. So I asked you to read through example 1, which you guys already did, and now we're going to look at it together. And you were to try to graph this. So the first thing I told you to do was to change the mode on your calculator. So if you go to your mode, okay, we should now be in parametric mode. Okay, now whenever we are trying to put in a variable, we usually use this button for x here. See how the second one is a t? Okay, and what's our variable for parametric? T, okay? And then our next one is theta, and that's for what? Polar equations. So like your mode, this just goes in order depending on whatever mode you're in. So we're in parametric. So when you go to y equals, what you should see is x sub 1 of t and y sub 1 of t, and we can plug our equations in here. Okay, so if you haven't already done this, do this with me. So we're going to have t squared minus, is this one 3? 3t. And then t minus 1, thank you. Okay, now my window is going to be different than yours. So when we graphed it, we only had part of an equation, which I showed you up there. Now, if I look at my table, in example 1, it gives me my t value starts at -2 and ends at 5. So if I do my t min at -2, ends at 5, and really you could just go by ones here. Okay, you don't even have to change anything else. All you need to change is that part, and you will get the same graph. Okay, so again, look at your t value. So look at your table. What's the lowest t value in our table in our textbook? -2 is the lowest t value, so that's going to be our minimum. And then our maximum is going to be what? 5. So all I did is I went to my window. My minimum is -2, my maximum is 5. And then I just kept my x mins and my x maxes. All I need is the t value, and it's going to graph it. So before, what was happening is you didn't have all of your t values. And if you don't have all of your t values, then you're only going to get part of the curve. So that's why a lot of us were only seeing, this, because you would have been starting at the value of t equals what?
0.
Okay, some people would have been 0, just depending on what yours were. It could be something else. So depending on what your value is, it is plotting those points. Now, a t also is going to tell us how the graph is being formed. So when you see the graphs in your book, did you guys notice there are little arrows?
Yep.
Okay, so the little arrows just mean that this is where you're starting, and then this is where you're ending up. So it's showing you that this is going to be the motion of the graph. Okay? Yep, so as t increases, you can show the position that's going to move along the curve in the direction of the arrows. You don't have to put your arrows on there. We're just going to label what our points are. Okay? And then again, I want to reiterate, it's going to be x, y. So if you look on your graph, for -2, all you're going to see is 10, -3. Okay? All you're going to see is 4, -2. So the t value isn't part of the graph. What's the purpose of the t value?
Input.
Yeah, it's your input. And that's how you're going to generate your x and your y's. Okay, very good. All right, so now we're going to look at our example 1. And if you haven't already answered, how can you adjust this? What I said is you could adjust the window to -2 as your minimum value of t. And then that would definitely help. Okay, so for part A, example 1, we are given an x equals equation and we're given a y equals equation. So you'll always have two equations, x and y. Okay, and most of the time they are going to give you the parameters of t. There might be some linear equations where they don't give you the parameters. And that's okay, you're just going to graph the straight line. Okay, but for this, our t goes from -3 to 3. So in step 1, it says first plot 5 points via the table. We're actually going to do more than 5. We're going to do the -3 to 3. So that means in my table, Haley, what t value am I going to start with?
-3.
Good, and I'm going to go up to
3.
3. Okay, so let's do that. And then you can decide how you want to solve this one.
I really think I hurt my head.
And you don't have to do that part
I
yet.
can't use it as my grade.
Okay, so here are your t values, and you can choose. You can either just plug those into your equation, or if you have your graphing calculator and you want to use your table, you can do that. Like the y one's going to be really easy, right? Because if it's t minus 3, what's -3 minus 3? Everybody, what's -3 minus 3? -6. -2 minus 3? -5? Yeah. Okay, so that's going to be an easier one to do. You can also go to your y equals, and we can plug in t squared minus 7t. And t minus 3. Now if you're going to use your table, make sure your table's set up correctly. So I probably would want to start at -3. What should the change in my table be? 1. So if you get to your table and you see a bunch of decimals for your t value, that just means you're probably using pi over 12, because that's what we're used to using in our polar coordinates. Okay, and I'm perfectly fine with you just writing down your points from the table, or you can plug them in. And then we're going to plot each of those on the XY plane. Okay, and I apologize because I should have given you a grid where you could make your own X and Y axis, but I didn't, so we're going to make that one work. Okay, so remember when you're plotting, you're only using what two variables? You're only using the x and the y. So Samantha, what's our first point going to be that we're plotting?
30 minus.
Good, okay, so your points from your table are going to be 30, negative 6, 18, negative 5, so on and so forth. Okay, so these are the points that we're going to be plotting. Okay, so you can go ahead and do that. Now, if I want to make sure that I get all of my points on here, what might be a good scale to go by? Yeah, 5 on your x. And on our y's, we can go by, you can go by ones. I know the one will be kind of off, but off the grid a little bit. Okay, so then let's go ahead and graph this. And then if you guys need graph paper, I will have some for you. Okay, so this is going to be 5, 10, 15, 20, 25, 30. And I think your 30 is going to be like a little bit off. And then my y's I can go by ones, and I think your negative 6 might be a little bit off. Say it again. Okay, so I'm going to plot my first point. Maybe I'll use. Okay, so 30, negative 6, so I'm going to go over to 30. 30 down to negative 6. And then my next point is 18, negative 5, so I'm going to estimate that one. 8, negative 4, so I'm going to estimate 8. 0, negative 3. Negative 6, negative 2, so here's negative 5, so negative 6.
And you just do the reflection.
Pardon?
Do you just do the reflection?
Nope, we're just plotting these only because that's our parameter.
Okay.
Now, when you find your rectangular coordinate, you're going to be able to see the whole thing. But for this, you're only going to do what the parameter tells you. Okay, but can you guys see that there's a slight curve to this? It is going to be parabolic. Now, what in your original equation would tell you that also? Yeah, you have the t squared in there. So you know it's going to be a parabolic equation. Now, when you're labeling, I think it just said label 5 points. So if you're going to label 5 points, we're just going to call them t sub whichever you'd like. So if I'm labeling this one, this would be t sub negative 3. This is t sub negative 2, t sub negative 1, t sub 0.
T sub 1.
Thanks. Yeah. T sub 1, t sub 2, and t sub 3.
How many do you need?
That. I just said to label 5. I'm just labeling them all, so you can label them any 5. So notice that this is going to tell you the direction that your curve is going. So I'm starting at t sub negative 3, and then I'm going to t sub 3. So can you guys see I'm starting on the positive side and going to the negative side? That's not necessarily something you would know, right? Sometimes you could be going this way. It just depends on your direction of your curve and whatever your formula is.
So you know it's going that way because it's going towards the positive number?
Yes, exactly. Yep, and you don't have to put the arrows on there.
Okay,
You
that's
can
what
if you want
Master
to.
gonna want us to.
No, that's okay. As long as you label 5 of them, that's fine. Okay, and again, I just want to stress that these points are not only going to give you the shape of the curve, but it's showing you how the curve is being traced out. So the order of points is going to matter. That's how the curve is being formed. And then the next thing we're going to do from this is we're going to eliminate the parameter, which when you eliminate the parameter, what you're doing is you're taking this equation that exists in the parametric field and we're going to translate it so now it's in the rectangular coordinate. So we also did that with what? Polar equations. Remember how we changed from polar to rectangular and vice versa?
Yeah.
Yeah. All right, you guys ready for the next one? Oops, sorry. Okay, so eliminating the parameter.
That's just making it rectangular.
Okay, when you're eliminating the parameter, this is also going to help us identify what the shape is. And when you're identifying what the shape is, if you are looking at it in the rectangular coordinate, you're not going to have any parameters on it. So it's just going to keep continuing. So this will be your full shape. Okay, so the definition of this, it's the process of finding the rectangular equation that represents the parametric equation.
So without
With, yeah, so really you're eliminating what variable? What part of this? You're eliminating the t. Now, with the algebraic ones, those are going to be a little bit easier. The trig ones are going to take a little more work. Okay, so because this one is algebraic, what we can do is solve for t and then use substitution. Do you guys remember what this is called when you're using substitution? Like what you're solving here?
No.
That you're solving systems of equations. Okay, so go ahead and do that. So you're going to solve for t in the simplest one. Okay, so Lexi, which one of these is going to be the simpler equation?
Why?
Okay, y. So go ahead and solve that for t. So go ahead and do that. Do step 1. Okay, so Regan, what'd you get for t for this? What does t equal? Okay, good. So t equals y plus 3. Okay, so Alex, what are we going to do with that equation?
I have no idea.
Okay, so it says after we solve for t, we're going to use what?
Substitution.
Okay, substitution. So when we say the substitution method, can you tell me what you do with that?
Plug in numbers for.
Plug in numbers for something.
No, don't plug in. No, if you're going to substitute.
I will remember as soon as you say it, but I will.
Plug in.
But, okay, see how this is t equals?
Yes.
Okay, so you're going to substitute this value in for t in where? Where else could
Oh,
we
in the
plug it in?
original.
Yeah, in the other equation, right? So if this is what t equals, we can plug that back into the original one.
F and G stuff.
Yes, kind of.
Okay.
Except you're just doing your substitution. Okay, so then Haley, you want to tell me what my new equation would be with that plugged in?
Y plus 3 squared minus 7 times y.
Okay, good. So you have to plug it in both places, right? So y plus 3 squared minus 7 times y plus 3. And then I'm going to give you guys a minute to simplify that. Okay, so the y plus 3 squared, Rachel, how do we simplify that?
Foil.
Yes, good. Okay, so you have to FOIL, you have to distribute. Okay, good. So, Luke, tell me what you Okay, good. So y squared minus y minus 12. How did that go? Good. Okay, so this we're done once we get here because we have an equation. Normally, when you have equations in the plane, what variable do you have it solve for? You usually have it solved for y equals. Do you guys know why this one is different? How you would know that? No, because there's still gonna be somewhere you have y equals. But how would you know this one has to stay x equals?
Because we're solving for x.
Well, so it's something we could look at in the equation, right?
The squared?
Yeah, the y squared, right? See how you have y squared and you have y? So because you have those, this is going to be what type of equation? What does it look like? The graph. Yeah, it's going to be a parabola. And do you guys know what type of parabola this is when you have x equals and the y squared?
No idea.
Sideways.
Yes, it's going to open sideways. So it's either going to open left or right. Do you guys remember that in chapter 12? It was the very last thing you would have done last year.
I don't remember doing that.
Yeah, it was in, you only did it if you were in A2H and you got to chapter 12.
I barely remember.
So it is going to be a parabola opening to the right, and then obviously if we had y equals x squared and an x, it would open up or down. Okay?
And that's if it's negative or positive. I know right or left, right?
Yeah.
I remember that.
Okay, so the shape is going to be a parabola for that. Now, for B, you're given two equations, and these two equations are trig functions. We can see our parameter is 0 to pi. And do you guys remember when we were graphing what we would usually do if we had a period and we wanted to scale our graph?
Maybe it's negative 3 current.
No, we would do something special.
Oh, change it to degree.
No, we divide by something. 4. We'd always divide the period by 4. So that's what we're going to do for this too. Now you don't have to, but remember I said you had to plot 5 points. So our first point is going to be 0. And then if I divide pi by 4, our first point is going to be pi over 4. Our second point would be pi over 2. Our next point would be 3 pi over 4, and then pi. Okay, so if you're counting, right, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And again, the reason why I decided to do that is because how many points do I get out of that? 5. And the minimum amount I said you had to plot was 5. Okay, now you didn't have to do that. You could have gone by pi over 5 if you wanted, pi over 3,
You can do whatever you want.
pi over 6. Yeah, you're still going to get the same thing.
So why would you divide by 4?
I decided to so that we could get 5 points. So if you take pi and divide by 4, you're getting these 4 with pi and then a 0. If you divide it by pi over 3, it would be 0, 1 pi over 3, 2 pi over 3, and then pi, there wouldn't be enough. But you could do pi over 6, and there would be more. That would be fine. Okay, so then let's find our x and our y values. So you guys can decide if you want to plug them in or if you want to use your table function.
And your y equals, do we change it?
You mean your equation?
Yeah.
Yeah, you have to,
Graphing.
right? Okay, so if you have a new equation, then yeah, you definitely have to put that in so it reads that, or else it'll just give you the same answers as you had before.
No, like with when it says y equals 2 cosine of t, do you have to make it an x equals equation? It's a circle.
No. Okay, and cosine of t. Okay, and then if you're looking at your table, this I would start at 0, and then what was my change in my table?
Pi over 4.
Okay, yep, so I'm going to go by pi over 4. So now when I go to my table, hey, I'm able to know that this is pi over 4, pi over 2, 3 pi over 4, and pi. And then I can plot those on my graph. You guys don't have to wait for me to plot those. Okay, once you have your values, you can decide what your scale is going to be. So you guys are already getting a good shape on there. Good. Oh, yeah. And for these, I labeled them A, B, C, D, E. You could do T sub pi, T sub 3 pi over 4 as well. Okay, and then again, remember when you're graphing the points. So 0, 2, 1.41, 1.41, 2, 0, 1.41, negative 1.41, 0, negative 2. Okay, and Nate, what kind of shape did this make? Yeah, okay, so you had a half of a circle. Oops, I'll show that. Were you guys able to plot your points okay? Yes. Yep, so with this one I used the A, B, C, D, E, so you would start with A, and then you would go to E for your direction. Okay, and then let's think back to our bell work today. So I asked you what types of functions were the Pythagorean identities. And there's one that I feel like we should all know by heart. Yeah, cosine squared plus sine squared equals what? 1, okay, so good. So we all know that the sine squared plus the cosine squared equals 1?
Yep.
Alright, I got a Valentine's Day joke for you about that one later. Okay, and the other two, you don't necessarily have to have memorized. Do you guys remember how you can manipulate this one? Yeah, Simon?
I just know that I think 1 plus tangent squared equals secant squared.
That, okay.
I know.
Yeah, you know how to derive it?
1 minus cosine squared.
Yeah, but do you, oh, that is one from this. But do you guys know how to derive the other two equations, like with tangent, secant, cosecant?
By dividing.
Yeah, by what?
By 1. 1 divided by sine, that's cosecant.
Is Alex whispering things to you?
No!
I'll
That
stop. I'll
was
stop.
rude. I didn't say one single thing to me.
He leaned
Oh,
over.
I did say
I'm
it.
angry now.
I looked at her because she was talking.
Well,
That was rude.
well, you said
I'm
that you
offended.
said to divide by 1, and if you divided by 1, what would that do?
Same equation.
Never mind. I give up.
I know what you meant
Just
though.
keep going.
I thought Alex was whispering things to you to confuse you, and so you were saying what you were telling me.
Going. I'm always confused. I don't need someone to help
Okay,
me.
so we're dividing, but what do we divide by?
You divide it by the sine.
Okay, yeah, you can divide by cosine or sine.
That's
So-
what I'm saying.
Yeah, you just misspoke. I knew what you were saying.
Thank you.
Yeah.
Someone's there for me.
Okay.
Okay, so if you divide by the cosine, sine over cosine is tangent, cosine over itself, 1, and 1 over cosine.
That's what I was trying
Oh,
to say.
snap, it makes sense.
At least you know
So then you could do the same for sine.
Exactly. So still start with the same one and then divide by sine.
1
That's
plus cotangent equals.
Okay, so this is our original one that I feel like we should know. Okay, and then the other two you can get from dividing.
I never knew that you could do this. But I
Just,
kind
you
of
just told Megan that that's what you were trying to say.
Because
You
I
never knew
figured
you
it
could-
out.
I was saving up
Okay.
for you, and then you're just digging yourself in all
I
over
figured
here.
it all out just now. I had an epiphany.
Yeah, we
I
did
understand
we did this for bell work one day, but it was back in chapter 7. Okay, so this is gonna be helpful for eliminating the parameter when you have sine and cosine. Okay, so you're really gonna have to focus with me on this one. And there's a couple different ways, so I am gonna show you a couple of different ways that you can think about this. So what we're trying to do is we're trying to find the rectangular equation. Now, we know from looking at the graph that this is going to be a what? A circle. We can tell because, look, the radius is 2, 2, and 2. You could also go out to 2 pi, and it would give you the other half of the circle. So, do we remember the circular equation with the center at 0, 0?
Can't you just reflect?
X squared plus y squared equals?
R squared.
Yep. Okay, so what we can do is we can use the equation of a circle and we can manipulate that equation. Okay, so what we're going to do is we're going to take the x squared plus y squared. This is the only part we're going to be interested in here. So the x squared plus y squared, okay, I want you to think about what x equals and y equals in this case. If you're not sure, go back up to the problem. So it's x equals 2 sine of t, and you have y
Is it
equals
2 parabolas?
2 cosine of t.
Is it 2 parabolas that you put together and then it's a circle?
Are you okay?
No.
Sounded right.
That, so once you are squaring these,
So you just square 2 sine of t.
yes, very good. Okay, so that's just what?
What?
That's just
That's
substitution.
just y equals 2
Okay.
cosine.
So what Samantha was just saying is if you have x squared, if x is equal to 2 sine of t, I can just plug this in. So this is my x squared plus my y squared. Okay, so all I did is substitution. We plug this in for x. We plug this in for y.
Equals 1.
No.
Oh my god.
Okay, so let's just slow it down.
Slow it down.
All right, so if we're going to square this, okay, when you square this, you're going to have to square both of them. So yes, the 2 squared is going to be 4, and then it'll be sine squared of t, and this will be plus 4 cosine squared of t. And then, Wahid, do you think you know what we have to do next? Yeah? Do these have anything in common?
4
Wahid, what do these have in common?
Oh, factor out the
Okay, so if we factor out the 4, no, you can't factor out the t because the t is stuck. It's stuck to the sine and cosine.
The answer is 4.
Okay, so now this is going to be what?
Oh my gosh.
Oh, well, that's 1.
Yep, so this is 1. But then, what does this equal?
4.
X squared plus y squared. So now, this is your equation. This is your x squared plus y squared equals r squared, which makes sense because if this is our circle, the center is going to be 0, 0. And what would our radius be? 2. Is that what we have in the picture?
Is this all the
Yep.
same problem?
Couldn't we
So couldn't we just
We
like
could have definitely
square
just
it?
done x squared plus y squared equals 2 in front of the point.
Yes. Right? Yep, but I would definitely practice because if you can just look at it and then write the equation, I probably wouldn't give you that one on your test. Okay, now let me show you one other way that you can do this. So you could also, you know how we started this by knowing that this is the equation of a circle? You could also start by knowing that sine squared plus cosine squared equals 1. And if you did that, you could plug in for sine squared and cosine squared. So if you have, or really all you need is sine and cosine, if you know x equals 2 times the sine of t, you could solve this for sine. So you would divide both sides by 2. So x over 2 would be the sine of t.
So inverse.
What would the cosine of t be equal to?
I don't want to know how to do it.
Cosine would be. I gotta find it.
Okay, so let's look at their equation. Guys, please be quiet.
Wouldn't it be?
So you're going to divide both sides by 2. So cosine of t would be y over 2. Okay, so now when you're plugging this in, you could do the sine squared. This would be your cosine squared. And that would equal 1. So if I squared both of these, I would have x squared over 4 plus y squared over 4 equals 1. Now, if these are the same, then you can multiply by the denominator. If these are different, do you guys know what kind of shape that is?
A parallelogram.
Yeah, what is it? Somebody said it.
Parallelogram.
No, Simon. No.
A triangle.
Thank you.
Ellipse.
Ellipse. Okay, so remember last year an ellipse is similar to a circle except you have one major axis and one minor axis. One is bigger than the other one. Okay, now because this one is the same, you can multiply both sides by 4 and you would distribute. So this would be x squared plus y squared equals 4. And you might have an ellipse, so we do have to know this method as well.
Why do we have to find out?
Wait,
I was
so-
showing you another way because some of them are not going to be circles, they're going to be ellipses.
So-
And so you would have to know how to write it in that form as
I
well.
have a quick question.
should-
I'm not trying to I just don't know what we're supposed to do with that information.
Okay, so what this is now our rectangular equation. So if I were to...
Okay, I didn't know what we were doing. That
Yeah,
makes sense. Okay.
yes. So if I were to graph this equation in the rectangular coordinates, I would get this function, which would be the circle, the center at 0, 0, the radius of 2.
Okay.
So like this would be 2 units there. Yep.
So should we just do the second method always if like sometimes the first won't work?
No, not if you think that that method's easier.
How do we know that it doesn't work?
Well, one way you could decide is from your picture, because with your picture, see how the radius was going to be 2 in every direction?
Yeah.
Yeah, so that would be a indicator that it is going to be a circle. If you started graphing it and this was out to 3 and these were both up and down to 2, then you know it's going to be an ellipse and then you should use the second method.
Okay, can you put a second method down?
For the second method, if it is an eclipse, how do you, what was the part with the denominators? Like, how do you multiply them out?
Oh, you wouldn't. You would keep it. So if it was different, if like this was 4 and this was 9, you would just leave it as x squared
Please
over
pardon
4.
interruption at this time. Please release the bowlers.
So this would
Bowlers will
be
be released at this time. Thank you.
okay, and then the next two that you're gonna do, you're gonna start those. Bye. Homework's online.
Get some strikes.
I used to have that.
Okay, so if some of you guys were still copying down the second method, it's right there. Okay, and the rest of us can try this.
Really, is Molly okay?
She's got the stomach flu after her mom took her phone away, so no one really knows what happened.
Yeah, she went outside. versa. You look so cute teaching.
Yeah, I swear my nose it gets so irritating teaching all the people.
Okay, so
Okay, stay focused.
I wasn't putting you down. I really thought that styles and words. And I thought you were just saying, oh,
I really did understand. I just
Yeah, she
didn't
just said
say
it wrong.
right.
I know that's why I thought you were saying that. I wasn't making fun of you or putting you down. I really thought that was very sense to you.
It would have been funny if you thought it was dividing us by one. I would have laughed, honestly. I'm sorry, but.
Okay, and then where's your X value?
What?
Where's your X value? Is this equal to X?
Yeah.
Okay, so that, and then is your square root of the whole thing? Okay, so then see if you can rewrite that in terms of y. Okay, so remember, in rectangular coordinates, usually the equation is going to start with what variable? If you're going to graph an equation in the rectangular plane, most of the time it's going to start with y.
Why?
It's normally going to start with y equals, okay? So for number one, I want you to write it in the form y equals, because there's two ways that you can write it. No. I mean for your final equation.
Oh, okay.
Okay, so you can decide what you want to do. There's a couple different ways. So remember, you want to solve for what variable? Yeah. Okay, so you can solve either equation for t. It honestly doesn't matter. I chose to solve the first one for t. So if I do that, then I'm going to get t equals x squared.
Did I do it right?
Yeah, sorry, I'm just thinking. I think it's 1 minus x squared.
1 minus y. Oh no. Is that the graphic? Because you have to divide it by a negative. Or you should do 1 minus y.
Okay, so I chose to square both sides. And now I can just plug this into my other equation. And I would get y equals 1 minus x squared. Now I didn't have to do it like this. The other way you could have done it is if you have y equals 1 minus t, if you solve this for t, you would subtract 1, divide by negative 1, and you'd have negative y plus 1 equals t. So if you plug that in, you would have x equals the square root of negative y plus 1. Do you guys know how we could solve this for y? Square it, so square both sides. And you would get x squared equals negative y plus 1, subtract 1, and then divide by negative 1. And then you'd have negative x squared plus 1 equals y, or y equals 1 minus x squared. Okay, so remember that when we were talking about the first one, we said that that one had to be x equals because of what? How did we know that one was x equals? Let's look at the equation.
Because it opened sideways. There was a y squared and a y.
Yes, there was a y squared and a y, so we knew that it was going to be a parabola. Kenzie, will you stop whatever you're doing? Thank you. And once you get this in the form y equals, that will be your equation. Now, for the second one, you see how you have secant and tangent? So we could start this by thinking of what? Yeah, or what? Yeah, or you can think of,
You can square both sides and make it.
The identity.
yeah, let's think of our identity. Do you guys remember the identity?
Tangent squared x plus 1 equals secant squared x.
Okay, so now what we have to do is we have to make these so that they are
Squared.
squared. So x squared would be,
Wait, what?
this is our identity, right?
Yeah.
Okay, so now what we're going to do is substitute. So I can't just plug in the secant. Well, I guess I could. This would just be what? We know that x equals the secant of t, y equals the tangent of t.
Oh, so X.
So this would be y squared plus 1 equals x squared. See how we're just substituting? If you plug in for tangent, tangent squared is y squared. Now this one has x squared and y squared in it. Do you guys know what format you would want that in for your
Y
final answer? No?
X.
Yes, you want both of them on the same side because what kind of shape is this? It'll be one of the, it'll be one of your conic sections, and whenever both of them are squared, you do want them on one side. So if I subtracted over my y squared, I'd have 1 equals x squared minus y squared. And x squared minus y squared would equal 1. And technically this one wouldn't be a circle, it would be a hyperbola, but the hyperbola is one of your conic sections. So anytime you have both of them squared, they're going to go on one side.
Wouldn't the one be negative?
What's that?
Wouldn't the one be negative?
No, I just switch sides. I put this here, I put this here.
Oh,
So I just swap those. Okay. And then I also put a little note on the side here, just that you can square both sides or add or subtract if you guys need that. You don't have to. Okay, and so your homework is pretty short. We're doing 3 through 5, 14, 17, and 18. And when are your homework logs due?
Tomorrow.